Okay, so let me introduce you if you've not met Jon before. This is Dr. Jon Exley, who's the Managing Director at Lynton. Do you want to say hi, Jon, and then the camera
Yeah.
function?
Oh, hi. Hi, everyone.
And my name's Hayley, I'm the Sales and Marketing Director at Lynton, and we're going to be walking you through, as I said this morning, the things that really make Lynton IPL unique. But I thought we'd start, first of all, just with an overview of who we are at Lynton. And I think these things that I'm about to talk about, they're really important if you are using a Lynton device, because they're actually things which you could be talking about in your marketing strategy. You know, you're working with the biggest laser and IPL brand in the UK, and there are certain accolades that we have as your supplier that you can repurpose into your marketing. So, for example, we are the UK's #1 laser and IPL supplier. So if you're not talking about the fact that you're using the UK's #1 in your marketing at the moment, then I think that that's something that you definitely could use to your advantage. We are celebrating our 25th birthday this year, 2020. And yeah, so we're set up in the early 90s from within a university. So we're actually a spin-off from a university, and that's Manchester University. And we've continued to manufacture our devices in the UK. So we are a British manufacturer. A high percentage of our portfolio is manufactured in our head office, which is just in Cheshire. And they are medically certified products that we sell as well. And we are authorised to produce those medical devices. So that's sort of our background in a nutshell. And we've got other webinars that go into that in a bit more detail if you'd like to watch them. You'll find them just on our YouTube channel. But something that perhaps a lot of people aren't aware of at Lynton is that we actually also sell devices for surgical procedures. So the device that you're actually looking at here, it's a German device, so we sell it on behalf of a company called KLS Martin. This is an absolute game changer when it comes to lung cancer, because it has the ability to actually, with just keyhole surgery, remove lung metastases, and that preserves patient quality of life quite significantly. So we're very heavily involved in supplying lasers to the NHS for surgical procedures, but also for aesthetic procedures as well. So we are listed on the NHS supply chain. And then we also have a different division at Lynton, which is conservation lasers. So this is lasers that actually clean museum artifacts, statues, buildings when the dirt and soot and pollution builds up on them. A laser is a really effective way to remove that build-up without damaging the underlying surface. In fact, it's the best way to do that. And so we actually have sold lasers globally to some really prestigious sites, like the British Museum, for example, all the way through to the Vatican. We actually had to donate to the Vatican rather than sell, but we thought that was acceptable. But they use our lasers to actually clean and look after their artifacts. So very similar process to our tattoo removal lasers, this one. And then we also we're sort of on the frontier a lot of the time of different developments with laser technology. So we regularly are approached by other companies who want us to manufacture devices for very specific purposes that almost don't exist currently. So, for example, we've been approached by some people within the nuclear decommissioning community to devise a device that's able to go into a building and help with the decommissioning of those nuclear power stations. And that means that, you know, there's less human interaction, so it's a lot safer, but you know, this is completely new and novel and something that Lynton have been at the forefront of in terms of developing this technology. And then, of course, a major part of our business is aesthetics. So we're definitely the biggest supplier in the UK, but we've also sold aesthetic lasers in 28 different countries. So we've got lots of scope across the world. And here in the UK, we're regular winners of lots of awards. Like, for example, last year we won the Aesthetic Award for Best UK Manufacturer, and we were highly commended in the training category as well. So, using this awards logo on your website, talking about the fact that you use an award-winning device is something that, definitely you can make the most of that. And if you are a Lynton customer, don't forget there is our online portal where you can go in and you can get access to all of these logos to use within your marketing. So we have lots of different devices. We really pride ourselves at Lynton at not just selling one thing, not one size suits all. We actually have 4 different devices for hair removal, for example, because there are certain things about your business that might mean that you want option A, B, or C, and we like to have a good scope, a variety of products to be able to retail. But one of the staples of our technology is our IPL. And our IPL is extremely popular in the UK. There are hundreds and hundreds and hundreds of clinics using Lynton IPLs and getting amazing, fantastic results. But often when we first start a conversation with somebody, we hear things like, well, is a laser not better than an IPL? Does IPL really work? Does IPL cause a bit too much skin damage? And these are frequent sort of comments that we hear from people. And the truth is that there are an awful lot of low quality IPLs out there in the marketplace. And unfortunately, that has given it a bit of a bad rep. But not all IPLs are created equal. And a Lynton IPL is completely unique and extremely different. And we're going to spend today just talking through why that is. So that should you have a Lynton IPL and someone call you and ask you, well, do you do laser or IPL? You have the answer to that question, because the reality is with your IPL, you can quite easily get much, much better results than someone down the road who's using a laser. It just depends on what that laser is. And you can definitely achieve fantastic clinical results, often over and above laser. So the reason that we can achieve such good results, and the reason our IPL is different, is because it is an IPL, so it is intense pulse light, but it is delivered with dynamic reflex technology. Okay, and dynamic reflex technology is something that is completely unique to Lynton, and it's how we deliver our light. Now, I've not really spoken about this so much in the past before. We've just sort of known that our IPL was superior and that it was great. And that's actually just a conversation with me and Jon where I was really sort of trying to get into the physics and understand, well, why is it so much better, Jon? How are we achieving these results when most other IPLs are not? And that led on to us saying, okay, well, we really want to communicate this to people. People out there, they know that their IPL is brilliant, but communicating that, we lacked in those tools. So dynamic reflex is a new marketing concept, but it's been an element of Lynton IPL for some time. And so, putting this in very simple terms, what does it mean? Dynamic reflex, what does it allow you to do? It means that with our IPL light, we can manipulate it to make it extremely flexible. The problem with most IPLs is that they are quite limited in how they deliver the light and the strength of the light or the energy within the light. Whereas with a Lynton IPL, you've got an abundance of energy. And because of that, you can use this dynamic reflexing process to deliver that energy in a really flexible way. And that's important because you are not just treating white skins and dark hairs. If you're treating white skin and dark hair, then you don't really need anything that sophisticated. That's perfect conditions to get good absorption of the light and to take those stem cells up to a temperature that destroys them. But the reality is that the people that come into your clinic are not all those brilliantly easy people to treat. Quite often you'll get people that present like myself whose hair is actually very thin, very fine, and very, 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 very light brown. Okay, and I'm a really difficult person to treat them. You then get other people that come in and they're a dark skin, they're a skin type 4 or 5. And yeah, if they've got thick dark hairs, that can be great. You can get a good result on that. But if their hair is, getting a little bit thinner and a bit finer, then they're a really tricky customer to get a result on safely. And then you have vessels, okay? A lot of IPLs, they just don't even work on vessels at all, okay? But a Lynton IPL not only works well on vessels, but it excels on vessels. In fact, our IPL was actually designed to mimic a laser. Originally, the whole concept of our IPL was, we want to make an IPL that's going to mimic the sorts of lasers that they use in hospitals to treat vascular lesions. Because if you can treat vascular lesions well, you can treat all kinds of hair well. Not white hair, I should add, but all the treatable kinds of hair very well. So, and this is the reality is, you know, you're going to get people that come in with rosacea. You're going to get people that present with extremely thin, small vessels, with dark pigment, with light pigment, with lines, with wrinkles, with thin, fine hairs, with thick, dark hairs. And so our dynamic reflex technology gives you the flexibility to get exceptional results across this wide bracket of people. Why is that important? Because your patient satisfaction on each person is then higher. If they get a result, they trust you, they recommend you, they make referrals for you, they spread word of mouth. It's easier to cross-sell them onto your other treatments. If they've had a good result with their hair, then selling them treatments for red veins is easy, you know. So it's all about making sure that you have a tool that, you don't have to look at people and say, well, I'm not sure we'll get a result on that, and turn them away. You definitely don't want that to happen. Anything that's treatable, you want to be able to get the best result possible on it. And B, getting that patient satisfaction really high when you treat people, because ultimately this is the best way to run a business, rather than just new people all the time, marketing, new person. You actually want to hold a steady base of customers that you cross-sell and make referrals and recommendations with, and sell other treatments to. It's a much more cost-effective way to market and run your business. And also, you know, I think you want to be in the position where you're saying to someone when you're treating their veins, yes, we are going to get a result. You know, you don't want to be worrying that there's somebody down the road with a more efficient device, which is, you know, you suspect is going to get a result, and yours won't. So it's important as an operator to have the confidence that you have a device that you know is going to get you that result and give you that high patient satisfaction. So dynamic reflex is really all about that flexibility and result, but in the safest possible way. Because the other option is you can just have an extremely high powered device, but it's risky in terms of causing adverse reactions, because that light isn't controlled very well, it's not delivered very well, and so you have a device which can just cause, you know, adverse reactions too often. So it's about the balance between that effective result and the safety as well. And the whole concept of Lynton IPL is built around the idea of delivering that effectiveness, but nice and safely as well. So essentially what we are going to talk about is how we manipulate our light, how our light is different, how we use the dynamic reflex technology to, you know, treat all of this huge array of things, which can all be treated very successfully with a Lynton IPL system. So what is IPL? Well, IPL is intense pulsed light. So, John, I may let you take one. Just talk to people about how the light's created, I guess, in the first place.
Yeah, thanks, Hayley. That's a great intro as well. I mean, I guess what I imagine we're going to do now for the next few slides is I'll just give you some of the inner workings of how IPL functions, but highlight why our IPL stands out from the others. And I'll refer back to a lot of work that was done when I first started in this industry in the mid to late 90s, where I spent literally 4 years of my life studying nothing but pulsing light bulbs, which is essentially what an IPL is. And what we see here is an arc lamp. This is what generates the light, of course, for IPLs. So it's different from a laser. In a laser, you'll have a crystal, and the crystal generates light, and the light's from a specific wavelength. Here we have 2 electrodes, an envelope of glass or quartz, and inside will be a particular gas, and we boost electricity through that gas, and it creates a plasma. plasma is the same stuff that like the sun is made of course. So it's like having a miniature drop of sun inside a handpiece. And that boosts out loads of light, but that's of all different wavelengths. And arc lamps were used for many years. Of course, that's what you use in a solid state laser. You use arc lamps to generate the initial energy that then pumps up a crystal and creates laser light. What we decided we could do was take the arc lamp itself and use that effectively for treatments, and that's what then became the first IPL. So intense pulse light, what's the idea? As with laser, we're aiming to get light into the tissue, to focus on a particular issue that we're trying to treat. So that might be hair or vascular. So we've got to focus on a particular target in the skin. We get the light in, it's absorbed by that target. When light's absorbed, it turns into heat. And if we can heat the target cells up to a sufficient level, we can destroy those cells and permanently restructure the tissue or the skin, essentially get rid of the target we're trying to get rid of. So that might be hair follicle, or if it's for vascular lesion, that can be blood capillaries, for example. So that principle, it's well understood. It's principle of selective photothermal lysis. Here's an example. Choose light to go into the tissue, make sure it's the right wavelength. It goes in. If we choose the right wavelength, it's absorbed by hemoglobin, in this case by melanin, then it's going to be absorbed by the hair shaft, heats up, the heat diffuses slightly, thermally diffuses outwards into the follicle cells, kills the hair follicle, and then it doesn't grow back again. So that's essentially how laser hair removal or IPL hair removal would work.
The same for vessels as well, isn't it? So if this were a vessel in the skin rather than the hair, it would just be a slightly different wavelength that you would use, and that vessel would absorb the light, and you would get a result without damaging the surrounding skin. And there are three cornerstones, I guess, to that balance between safe and effective treatments. Three things which will determine whether or not you get the safety and you get the efficacy. So it's not just about the fluence or the energy, the power, so to speak, that you're using. It's also the wavelength.
Yeah.
And with IPLs particularly as well, the pulse durations and the pulse sequencing.
Yeah, I mean, that's a critical thing with all of this, is that whenever you design any piece of technology, laser or IPL, you have to balance these things off against each other. Now with laser, that's fairly straightforward because wavelength is fixed for a laser. You know what you're going to get. Pulse durations are relatively fixed, and then you get a particular energy out. That's it. What was the issue with IPL, and certainly in the early days when we were designing them, was suddenly for the first time ever, we had the opportunity to vary all these things. We could choose our wavelength, we could choose our pulse length, we could get out different fluencies. So the question then is, well, how do you optimize each one of those to work together in perfect balance to deliver safe and effective treatments? Because it's very easy to get that wrong. And in fact, that's what we spent years working on, was to get this perfect balance right. And that's what makes the difference really between different quality of IPL, is those that perform well have got this balance just spot on. And that's not trivial, not at all. I mean, that took a lot of research to get to that point.
Mm-hmm. So as Jon says, it's about looking at these three things and making sure that you have the balance of the three. So if we go through them just in a bit more detail, we start by looking at the wavelength. So it basically, in order for you to get the hemoglobin or the melanin to absorb the light, it needs to be the right wavelength. And wavelength essentially is like the colour of the light. So you need, for a vessel, you need certain wavelengths. For hair, you need certain wavelengths so that they can absorb the light really well, so that heat can be targeted where you want it to. Wavelengths are measured in nanometers, and Lynton IPLs emit from 550 to 1100 nanometers. And then what we do is we use a filter to filter out the exact color that we want. So whereas Jon mentioned earlier, a laser is one fixed wavelength, with IPL, you've got this flexibility of wavelengths, this essentially white light, which you can then use a filter to give you exactly what you want, essentially, in the light itself.
So in fact, we could actually emit even more if we wanted to. The flash lamp itself goes down to even shorter wavelengths, but they're not good wavelengths to be put into the tissue. So we need to extract those, really, make sure they don't get out of the handpiece.
There's what you're looking at here is just how easily melanin absorbs different wavelengths. So this black line is your melanin, and you can see as it comes across the screen here that it decreases in how well it absorbs these different wavelengths. So you've got, you know, some very common laser hair removal wavelengths in here, some vascular ones, the KTP and the pulse dye laser, just a little bit further along. So in this sort of 550 to 650 bracket, you get really nice absorption for vascular lesions. Hair is quite flexible, so you can use a really wide range of wavelengths for hair. And as we said, the beauty of IPL is that you're from 550 up to 1100. So you've got all of the sort of opportunity, so to speak, within that bracket of wavelengths within IPL, but you filter out what you want for specific treatments. And so what you can see here is a Lynton handpiece. Within here, you would have the flash lamp, just where the sort of Lynton is written on the handpiece there. You've got your flash lamp, and then where that 585 sticker is where your filter is. So you can see the red filter just off to the side here, and that's us filtering out the light onto the skin. So with Lynton IPL handpieces, there are two handpieces. There's a 650 nanometer handpiece, so we're preferentially filtering out 650 and above. So that's your hair removal and your skin rejuvenation. And then we'll allow some lower wavelengths out with the 585 handpiece for our vascular, our pigment, and our acne.
It's probably worth saying, I guess, at this point, Hayley, that there are IPLs that use multiple filters.
Yeah.
And it's certainly something we've looked at many times in the past. In fact, we designed 3 or 4 other filters for different applications in the past. But in fact, what we found clinically is that small differences in the filters doesn't make a huge difference to the clinical outcomes with our IPL because of the energy and the pulses we're using. So we found, for example, we did a great study up in Glasgow Royal Infirmary. We thought we'd launch an acne treatment. So we designed a couple of new filters, sent them up there along with our traditional 585 handpiece, and the net result was they couldn't see any difference in the clinical outcomes. The 585 was just as good as the other 2 filters we designed. Well, we could have launched that, of course, and sold another handpiece, but I think we felt at the time that the right thing to do was to just demonstrate the results, and people who had the 585 could have a new treatment just for a simple software upgrade. So there's no need to have multiple filters in our IPL from what our research has shown us. And in fact, I think it's safer not to have too much confusion. And certainly, there are some handpieces where the filters slide in and out, which I think is very dubious, because knowing how filters work, it can be highly susceptible to damage from grease or dirt. And once a filter is damaged, of course, it's letting the wrong wavelengths through. This is your barrier to safety, because this is what stops wavelengths of light coming into the tissue that you don't want to deliver. So we lock our filters into our handpieces to prevent dust and dirt and grease damaging the input face of the filter. And then the handpiece is intelligent, so it knows what filter it's got in. You can't plug in the wrong filter by mistake, and everything flows. It's all about safety, but being effective.
And I mean, we have seen that as well. We have seen people who've had skin trauma, they've had adverse reactions because there's just been the coating on the filter has just been knocked off, been scratched off. And you can imagine, you know, if you are using, you know, these handpieces, they get hammered, don't they, day in, day out, people are using them. And if you're clipping in and out different filters from within here, and those filters are just being, you know, placed in boxes or wherever, lots of different operators all at once, it's very easy to chip them or damage them and cause an adverse reaction. So it is much safer to have them actually built into the handpieces. But we also are quite different to a lot of other IPLs, aren't we, John, in the way that we can get quite high energies from just a narrow band of filters.
Yeah, and I think that's important to explain, really. I mean, the first thing worth noting, I don't know whether people know how filters work, but, you know, there are filters where there's just glass and it's different colours. You know, like in a stained glass window in a church, the light comes through, you can see different colours. That's because the glass itself is coloured. Well, the filters we use aren't just coloured glass. They are pieces of quartz with special coatings on that precisely reflect light that we don't want to go through. It's called dichroic coatings. And that's why they're susceptible to damage, because they're coated. So IPLs that use this methodology, they can't, that's why you've got to be very careful about sliding them in and out and getting dirt and grease on them. So they're not just bits of coloured glass, they're very sophisticated quartz filters, really, with very delicate coatings put onto the outside. We use them essentially because we've got all the colours of the rainbow, as you can see here, firing down out of the lamp, heading into your skin. And so we don't want all the colours, we're trying to pick a target. So we know from the physics, if we're going to pick a target, we have to concentrate just on the wavelengths that we want to go into the tissue so that the light can travel through the skin, won't be absorbed by things that we're trying to protect. And as soon as you hit the target, like melanin in a hair shaft, all that energy is absorbed, in it goes, and it heats up. So if we were to put the filter here, you'd see the light traveling through. We use a 650 for hair removal. And because, I think we're going to come on to this, because we've got a lot of energy in our pulse, we can be very selective about our wavelength range. We can make this more like a laser, keep it very narrow. So for hair removal, we use 650 to 1,100 nanometers. And we get a good fluence, up to 40. I mean, anyone with an X-Lite's probably never cranked it up to 40, unless, you know, you're really going hard. So there's plenty of energy, but we keep a very narrow band of wavelengths to avoid absorption into things in the tissue that we don't want to damage. Now, I have a little joke. You know, it's easy to make an IPL in principle. You can just put a light bulb in a box. The problem with that is it's all about the balance between wavelength and fluence and pulse duration. Now, one way you could, for example, if you were unscrupulous, want to make an IPL look more attractive on the specification sheet, is you might find that you've got an IPL, you've shoved a light bulb in a box, you've chosen a Lynton filter because you thought that's a good choice. But what you find then when you pulse it is your energy out is really weak because you haven't got the dynamic reflex that gives you a lot of power, a lot of energy. So the same filter on a different IPL might only deliver, as you can see here, say 15 joules per centimetre squared. And that would be limiting to what you could achieve because it's not strong enough. So if I want to make my brochure look a bit better with a higher spec, I could change this filter and I could start to allow more wavelengths through, because what that will give me is an ability to put a higher fluence on my specification sheet. So to get to 30 joules per centimetre squared, I change my filter, I open up my wavelength range, I allow more light to come out of the handpiece and into the skin. And now I can say, you know, I've got a 30 joules per centimetre squared output on my IPL. What's not clear is what's the wavelength range in which you get 30. Because the point here is this is not a great wavelength range for the treatment anymore, because it's not selective. You're now allowing wavelengths to go into the tissue that aren't the ideal solution. In fact, they're possibly dangerous. And so what we managed to do with our IPL, this balancing act, is to keep a very narrow wavelength range, the correct wavelength range for the treatment, but simultaneously, at the same time, deliver the right level of output fluence or the power is strong enough to do what we need it to do for an effective treatment. And that's safe because you've got a narrow band of light, but effective because you've got all that fluence. And that's what you don't get across all IPLs. Does that make sense?
It does, yeah. So, as well as, well, we've mentioned actually a few times already the fluence being an important factor. And so we just thought we'd walk you through how we've managed to create this abundance of energy to be able to use this very select range of wavelengths and to be able to pulse it in the way that we do. So, what is the fluence? You know, an easy way to describe this is, you know, sort of the energy, the power, but fluence is actually, you know, measured in joules per centimetre squared. So it's like your energy over area. It's a measure of, you know, how much, you know, higher fluences are going to be needed for thinner hairs, for more difficult things to heat up. You know, you need to put a little bit more energy into those. If you use a fluence that's too low, you'll find it difficult to get a result. And if you use a fluence that's too high, you can overheat the tissue. So one of the things that we have done within our assembly of the handpiece is used quite a specialised reflector. And we've also used quite a unique lamp design. So we'll just talk now about the reflector and the lamps, and I'll hand back over to Jon, who's going to talk you through this, because this is really your area of expertise, isn't it, Jon? This is sort of the making of your PhD.
Yeah, so I dug it out of the loft. This is my PhD thesis, if anyone can see it here, which was 4 years of work in this one book, and I use it as a doorstop now, but that's because it's so old. But I mean, in all seriousness, it took many years to design this in its detail, and many mistakes were made, you know. When we work at university, just going back to the filters, I did start off with coloured glass, and as the lamps got more and more intense, it would smash the glass, so we had to design those specially coated filters. And I think what I want to tell you now isn't really the story of how this came about. A lot of the principles were worked on at the university. Of course, 25 years later, we finessed it. We keep adding to our design, improving stuff. But bear in mind that this principle, dynamic reflex, although it appears to be, you know, something new today, it vastly improved from what it was when we first developed it. But many of you, Lynton IPL, will have the core principles already in your handpiece. You can use this marketing already because your IPL has a lot of the facilities that we're talking about today already built in. And over years, they've just been improved bit by bit. And then the thing to point out then is how does it work? We've got our lamp. We talked about the lamp earlier, and I'll show you a picture of the lamp in a second. That generates light with a huge pulse of electricity going through it. But that light comes out in all different directions and all different wavelengths, as we've mentioned. So we have a specialized reflector behind the lamp, and that channels any of the light that's coming out. It collects the photons and pushes them out in the direction that we want them to, towards the skin. We put a filter in place, and that selects the wavelength range we've talked about. And then, of course, it gets launched into the quartz light guides, the ILG technology that we've had for a number of years now, and that channels the light down and into the skin for the treatment you want to achieve. I think it's worth talking about the lamp first of all, just briefly really, because this I think is a very important factor that isn't always well understood. The lamp itself is a quartz light guide. I think there's a picture of it, Hayley, on the next slide. So it's like it's got there's a quartz sort of jacket, we call it, and 2 electrodes. And you know, you could get hold of a lamp, you can put it in a box, and you can pulse electricity through it and create an IPL. But what people don't often understand is there's a dynamic of the relationship between the lamp and the power supply that creates the electric pulse in the IPL. And the two work together in harmony. And we had to design both the power supply and the lamp to function correctly together. What I mean by that is the electricity that goes through the lamp works in a certain way to give a light output pulse. And that's based upon the design of our power supply and the design of this lamp. So the lamps we use are uniquely designed for Lynton IPLs. So we designed the length of the arc, we know what the electrodes are made of, the jacket itself. Good example, the jacket, originally lamps were made of quartz. They allow all the wavelengths to come out. And as we were designing the IPL, we realized that UV is obviously something you wouldn't want to emit into tissue. You could try and filter it out with the filters themselves, which we do as well. But I discovered you could actually put a special chemical into the quartz envelope, the jacket of the lamp, that filters out UV. So our lamps don't give out UV at all. The special thing really with lamp is lifetime. If you want to pulse it hard, lamps don't always last as long as you want. If you balance the power supply with the lamp design as we've done, what we have is very, very stable outputs. So across the entire lamp lifetime, we aim to keep our output within plus or minus 5% of what it was at the start. So it's very, very consistent. In fact, the medical device regulation asks for that to be plus or minus 20%. We aim for 5%. And that means that as you pulse, it doesn't matter what treatments you do, the energy compared to what it says on the screen will always be clinically effective and won't change, so that you won't see any noticeable difference. Many people, when their lamps start to get older on different IPLs, you find that the lamp is degrading and the energy output is dropping bit by bit. We've designed our lamp to work with that power supply, so the power supply knows exactly what current goes through the lamp and keeps that energy constant. We actually have some electronics in our IPLs. We call it Pulse Guard, and the electronics constantly monitors each pulse of electricity going through the lamp. And with a Lynton lamp in the IPL, it will know precisely what it's going to give out. If someone put a different lamp in there, the Pulse Guard wouldn't be able to tell precisely what energy is coming out. It might be variable. Or if someone made an IPL where they hadn't thought about the lamp and the power supply, how they work together, then you will get a lot of variability in your outputs. So that's something I don't think many people understand, that the lamps are specifically designed by us for our IPLs to give that absolute consistency and avoid any issues. I mean, clinically, what that means is you get used to treating someone on a particular fluence, and you get a lamp change, and that you'll see a big difference in the output energies or output fluence that you're using because of the degrading lamp, where you shouldn't get that with a Lynton system.
Mm. Yeah, and it's not uncommon for us to see lamps that, or systems that claim 200,000 shots, 300,000 shots, and the reality is you cannot do you cannot allow a lamp to do 200,000 shots unless it's at a really low fluence. It's like it's a warning sign in itself if any lamp will do 200,000 shots, because the fluence will be limited to allow it to do that. The pulsing will be limited, so you will get quite compromised results. And also, as Tina's mentioned here, you do have to be a bit careful if you're buying a Lynton device secondhand, that you are, it has been serviced by us. We make sure it's got our lamps in. If you can find companies that will offer counterfeit lamps to put into your system, but there is a risk there that could cause you an adverse reaction, which of course your insurance company wouldn't cover you for, because you'd not had it serviced and looked after by the original manufacturer. And it's just, ethically, it's hopefully you can see now how the lamp is really, really important. So for your own patient safety, please do make sure that you're using the correct lamps.
It's a really good point, that, Hayley. If you put in the wrong lamp, the electronics don't automatically know. It's all calibrated perfectly for that lamp design. If it's a different lamp design, then the calibration won't automatically be correct. So. I think the big thing though with the IPL, and this is where it absolutely shines, excuse the pun, above anything else, is pulse duration. And that's been developed again over the years. It's got much better because we've been working on the specialised reflectors that we have in there. Why is it so important? Because traditional IPL, and again, this is the main factor actually on lamp lifetime is the on time. The on time on an IPL, if you want to make your lamp last longer, then make sure the on time is as long as possible. And so all IPLs now, I think, pretty much deliver a sequence of pulses. So a pulse and a bit of a delay and another pulse. And in that sequence of pulsing, you'll have what's called the on time. That's the time when the lamp's actually flashing, and then it'll stop momentarily, there'll be a little delay, and then it'll flash again. And you can almost sense that with a Lynton IPL when you put it on the long delays and you press the button. This all happens in milliseconds. You can almost sense like a pulsing technique, which is used regularly. So most IPLs have quite long on times. And again, that's because the lamps will get hammered. They're difficult to make a good lamp last long unless your on time is quite long. The problem with that, yeah, sorry, go Hayley.
I guess just sort of coming out of the physics brain for a minute and sort of looking at this commercially, it's about the fact that, so we're going to go on now to talk about why do you need short on times, why do you need long delays, but just have that sort of in your mind about the flexibility. Okay, so all these different conditions in the skin, they need different conditions of pulsing. So the more fluence that you've got, the right wavelength that you've got, this and that, everything that we've talked about so far, the flash lamp, the interaction with the flash lamp and the power supply, it's all about giving us that abundance of energy so that we can actually pulse in this way. We can have really short pulses, long pulses, we can have big trains, short trains, sequences, I should say. So yeah, it's all about the flexibility in the treatment room to allow you to treat different things, isn't it, John? So there is a difference between what you treat with a short pulse and a long pulse, isn't there?
Yeah, and I think we're going to explain that in a second, aren't we, the thermal relaxation time. But this is absolutely, Hayley's spot on with this. You see, selecting wavelength is very important, but selecting pulse length is equally, if not more important, in making sure your treatment site is, you're selecting your treatment site. So you're not destroying skin or damaging skin that you don't want to damage. So we can deliver essentially what we call sub-millisecond pulses as an on time, as opposed to most IPLs, which 4 was considered quite short. They're probably 7, 8, 9, 10 milliseconds long. And you'll see in a moment why that's so important for a clinical outcome. So this is the key here. We can deliver very short pulses, and we have flexibility over how we deliver those short pulses as well. Whereas most IPLs have a limitation in how short those individual on times can go. And this is why it's so clinically important, I think, on the next slide, is it, Hayley? If you, essentially, this is something called thermal relaxation time. This is the balancing act between wavelength, fluence, and pulse duration to get a safe and effective result. And the way to think about this is that different objects cool down at different rates, okay? So a good example is if I run a very hot bath and I go down and make a cup of tea, so I want a cup of tea in the bath, and I go down, I can make my cup of tea and I pop it on the side of the bath, someone rings me, phone call, 20 minutes later my tea's gone cold, but my hot bath is still warm, still hot enough to have a bath in, because it takes a lot longer to cool down. And why? Because the bath is much bigger, the object is bigger, it holds more heat, it takes a long time to cool down, whereas my small cup of tea cools very, very quickly. So the key here is different things cool at different rates, and the bigger they are in general, the slower they cool down. Small things cool down a lot quicker. Now, if you relate that to the skin and to hair, for example, you've got a great big hair shaft there in the skin full of melanin. We also have some melanin in the epidermis. Now, if we take a long pulse duration and zap in the light, now if this pulse duration is too long, what will happen is the light goes in, it starts to be absorbed by the melanin, and it turns into heat. That's great, that's what we want. We're trying to keep all of that heat just in the hair shaft itself, because we don't want it to come out and damage all the skin around it. Or for example, if you had a very fine hair, you want to confine it all to that hair shaft where it's very thin, because if the heat comes out too much, you never get to the high enough temperatures to cause damage. I hope that makes sense. So a long pulse would be great if you've got a big, thick hair and very white skin, for example. If you had a much lighter coloured hair, I want to now make sure all of that energy gets into that hair follicle. That's fine, I've chosen the right wavelength. But if I have a long pulse, as the energy is going in, it's leaking out. It's like having a bucket with a hole in the bottom and pouring water in the top, but it's leaking out at the same time. And never get the bucket full enough and never get enough heat into the hair shaft to cause that damage permanently, to destroy the cells. Now, if I use a very short pulse, that's like I still got a bucket with a hole in, but I fill it up so quick that it gets high enough quickly. Does that make sense? Before the water can leak away. And that's what you do with a short pulse of light. The light zaps in, the temperature rises quickly, and it's not had time to thermally come out of the hair shaft. And so all that energy now creates a strong enough heat, a temperature high enough to destroy that fine hair that's very, very difficult to do with any other technique. Okay, so it doesn't matter if you've got the same wavelength in the IPL. If you cannot deliver the light in that incredibly short pulse, then you'll be limited just treating certain types of hair. And that's where the difference in variability comes in, to allow you to do different things, to treat more challenging cases. You need the ability to go to very short pulses. But the times when you don't want that, of course, like I said, you might want longer pulses for big, chunky, dark hairs, fantastic. But it's about being able to vary and get what you want when you need it, rather than be stuck with a limitation on what you can achieve because your IPL can't have that variability. Does that make sense?
And even when we see very good quality IPLs on the market, because there are some other good quality IPLs, there's still a big difference in that on time that they can achieve. So if you think of, I guess, one of our sort of one of the popular quality IPL systems out there, I know, without mentioning any names, that the specifications are that the shortest on time that they can achieve is 4 milliseconds. Now, 4 milliseconds, that's not across the whole sequence here, it's just one of those pulses. Even if that were 2 milliseconds, it would be double the length of Lynton, sometimes triple, because we are extremely unique in that we can achieve a sub-millisecond pulse. So if you look at a pulse sequence like this from a Lynton IPL towards the bottom of the screen here, you've got a pulse and a delay, a pulse and a delay, and each one of those pulses has an on time, so that's the short pulse, of less than, it can be, depending on how you set the machine up, it can be less than 1 millisecond. So it is rapid heating. And that is why, I've been in sometimes to train people, and, they were using one of our competitors' systems. They just upgraded to a Lynton. They put a model in front of me and said, oh, she's had so many sessions, I don't think we'll get any more of a result. What do you think? And I said, yeah, we'll definitely get a result on those hairs. It allows you to treat hairs that most other IPLs just would not be able to treat at all. Super short, rapid pulses for very thin, very fine hairs. And this is particularly useful with rosacea. So with rosacea, you've got extremely small, thin vessels, and they need incredibly short pulses. It's the reason why dermatologists in NHS hospitals buy Lynton IPL to treat their vascular concerns like the rosacea, like the port wine stains. It's why our IPLs are very popular in NHS sites for that reason. And in the treatment room, it just gives you exceptional results.
Can I just mention as well, I mean, the reason this has come about is due to the reflectance, really, of the specialised reflector. It was originally, I was working on trying to get more energy, but we were so successful in developing this reflector, which is a very unique thing for Lynton. We got so much energy, I realised that what we could actually do was deliver. We had too much energy almost, so we could just shorten the pulse, these sub-millisecond pulses, and still have enough energy to do a good treatment. And that's the thing, isn't it? You could shorten your pulse, a bit like with the wavelength range. You could extend your wavelength range, you can shorten your pulse. But can you still deliver the right amount of energy at the same time? And that's what we can do with ours for the treatments for, like you said, red veins, capillaries, very, very tiny objects in the skin need short pulses to get good results. I mean, laser pulses that we use traditionally, pulse dye laser, they're sub-millisecond pulses. And that's what we were trying to replicate when we first designed this to treat port wine stains.
So the other thing then, looking at it from the other end of the scale, is, well, how do you make that safe? How do you manipulate? Because this is brilliant for really, really fine hairs, perhaps lighter skin types 1, 2, 3. But when you start to get into skin types 4 and 5, then we actually need our IPL to function very differently. Most other IPLs have a fixed pulse train. They deliver 2 pulses or 3 pulses, sometimes 4 pulses, and you can't vary that, and that makes it really limited. Whereas with the Lynton system, you can do anything from 2 to up to 6 pulses, depending on which device that you have. And having 6 pulses then means that we can deliver the light in a way that really maximizes the skin protection. So we're going to talk through now why a series of 6 pulses would be an advantage, and why we've also got these delays in between the pulses, and how those delays help us to just keep everything as safe as possible on the darker skins.
Yeah, this goes back to what I said before about different things cool down at different rates. So when we're treating hair, of course, we're aiming for melanin, and we've got melanin in the hair shaft. But if you've got darker skin types, that's just a sign that you've got more melanin in your epidermis. It sort of resides on the epidermis and the dermal boundary. And of course, when you put the light into the tissue, we're aiming for melanin. So we've designed the wavelength range, going to target melanin. We're trying to attract heat into the hair shaft. But of course, at that point in time, the epidermis will absorb some of that light as well, and so it will get hot, like the hair shaft does. So what we're trying to do in our treatment, make sure the hair shaft gets hot enough that it's destroyed, that the hair shaft itself dies and we get rid of the hair. But of course, we're trying to protect the epidermis. We don't want to damage the skin itself, do we? So we put in a sequence of pulses. First pulse goes in, everything gets a bit hotter. But the epidermis, the melanin there is much, much smaller. It's also based near the surface of the skin. We put gel on the tissue, and it takes the heat out of the epidermis very quickly. So if we put a little delay into our sequence, we can let the epidermis cool a bit, whereas the hair follicle itself, that's much bigger, isn't it? Remember, like a hot bath, that stays hotter for longer. So then we let the next pulse go in, and then it cools down again in the epidermis, but the hair shaft itself gets a little bit hotter. And we do a sequence of pulses, one after the other, because what we're doing is bit by bit, we're increasing the total heat of the hair shaft. Every pulse goes in, creates heat in the hair shaft. The hair shaft doesn't have a chance to cool down sufficiently before the next pulse arrives, so it just gets hotter and hotter and hotter. But in each of those little delay times that we put into the sequence allows the epidermis to cool down. And so we eventually get a really good differential in temperature. The hair shaft is much, much hotter, and the cells can be destroyed, whereas the epidermal melanin has sort of heated and cooled. I think it's a diagram to demonstrate this now. And this is why it's important, because at the end of the day, we want a really clear differential between the two temperatures. This is about margin for error, which I'll explain in a second. But if we have, this is a graph of time and temperature. So if you imagine this is the temperature and you can see the pulses above, if we were measuring the temperature of the epidermis, which is the green line, and the hair shaft or the target, which is the pink line, the first pulse of light would go in, and you'd find that they both get a bit hotter, wouldn't they? When they're both absorbed, they both get hotter. But you can see there's a line there called damage threshold. So that's the temperature. It's typically about 70 degrees centigrade. Above that line will destroy the cells permanently. And that's what we're trying to do, of course, with the target. What we don't want to do is do that with the epidermis. So we can see we've got a bit of heat here. Now you can see it's on an upward curve. If we carry on just putting light in, it would just get hotter and hotter and hotter, and then we'd have a risk to the epidermis. So we have a little break, we put in a delay, and both will cool down. Okay, so the hair cools a little bit. The epidermis cools a lot faster than the hair, so it gets cooler quicker. And then we get to a point where, say, right, next pulse goes in, zap. Both things heat up again, but give it a bit of cooling time, have a delay. And over this sequence now, the hair shaft is getting hotter and hotter. And eventually, the hair shaft itself gets beyond the damage threshold. That's great. That's just what we want. But we want that to happen so that, obviously, the hair shaft dies. The epidermis has gone through a sequence of cooling and heating, but remains well below that damage threshold. And so now we can destroy hair or capillary in the skin, whatever the target might be, but leave the epidermis perfectly unharmed during that process. There's a big gap there between those two temperatures, and that's what you want, because, of course, we're not measuring the temperature in the skin, are we, as we do these treatments? And we want to know that the IPL is designed to give that a big gap like that, because, all you're going to do, all we do as practitioners is to treat the skin. But what we've done is a lot of research so that we set up our skin types on the IPL, skin types 1 to 5, and you program that in as a practitioner. And this pulse sequence is all set up perfectly with a large temperature gap designed so that you can treat the hair effectively, get a great result, but safely by protecting the epidermis at the same time. Now, if you didn't have that design done in that way, it would be very difficult to judge that gap. And as a practitioner, I don't think you should, it's not something you can judge as you treat. You need to rely on the technology you're using to deliver that for you, especially.
And you can imagine, can't you, for those of you that know our systems and use them, you'll know yourself that, if you're treating hair removal on a light coloured skin, it's usual for it to give you 2, maybe 3 pulses. But when you set it up to treat a skin type 5, you'll see that it's doing 5 or 6 pulses with quite long delays, and you can shorten or lengthen those delays, at your discretion. But you can imagine if you did have a system that didn't allow you to be flexible in the delays, that only allowed you to do 2 pulses, you would be compromised there, and you wouldn't be able to get that great temperature difference, as Jon explains, and ultimately the results just won't be as effective. They won't be as safe on the darker skins. They won't be, well, the reality is, because if you've got IPL systems that limit you to 2 or 3 pulses, quite frequently they will also limit the fluence. So when you set it up for a skin type 3, because they know that that's a skin type 5, because they know that that's being delivered only over just 2 or 3 pulses, the fluence number that you're given is very low. So then it's just more, unless you've got thick dark hairs, it's a lot more tricky. So where this technology really comes into its own is if the hair is that little bit thinner, then you'll get a better result with a Lynton IPL on a darker skin than you would with your traditional type of common IPL that's out there. And that's all really down to this dynamic reflex. So yes, it's a very high fluence system, but that abundance of fluence really allows us to deliver the light with dynamic reflex in this incredibly flexible way.
Yeah, spot on. And then I guess the last thing, the ILG technology, interchangeable light guides, are, you know, the last bit of delivering that light into the tissue. And even these are designed specifically to work perfectly for the operator and limit, again, create safe and effective treatments. We have interchangeable light guides, so we have different sizes, don't we? I think Hayley's got some examples she can show us.
Yeah. So you can see there's three different interchangeable light guides on the screen there, and they just clip in and out of the handpieces like this.
So the idea of the interchangeable light guides, of course, is, you know, we're treating, it's all about flexibility. We're treating different targets and you know, and the skin. It might be, if you're doing hair removal, for example, you know, on the whole, you want a bigger block to treat large areas as quickly as possible. That's completely understood. And in fact, most IPLs then have a large light guide, a large area. It's hard to make them interchangeable. You need more energy to do it for a start. Every surface is a reflection. If you have them interchangeable, you do have to be delivering more fluence to be effective. If you have a big light guide and it's locked into your handpiece, which most IPLs do, and you want to treat something small, like a little capillary around the nose, then I don't know, there's various techniques. People put masks on top of them, little cut-out bits. But if you imagine trying to position that on a tiny capillary around your nose, incredibly difficult to be accurate, to be safe, you know. So we have interchangeable light guides. You can put in a much smaller light guide. In fact, the one that's fantastic is the round one. Yeah, so Hayley's showing like the round light guide there. It's perfect for treatments around the nose. Why is it so important? It's important because a small capillary is very narrow. We don't want to overheat all the skin around the capillary, do we? You know, you just want to target the vein. So people with larger light guides either have to try and mask off part of the light guide to reduce the energy going in, or they're going to just blast the whole skin all around that capillary with excess energy that you don't want to be in the healthy tissue. So we change our light guides so that we can use what we call spatial selective targeting. So the light that's going in is largely hitting the target and not all the skin around it. And so by changing those light guides, you essentially reduce energy that's going into tissue that you don't want it to go into. So it's making it safer. You're not overheating or bulk heating tissue where there is no target. So changing the light guide, again, produces a safer treatment because you confine the energy to more of the area where your target is. But of course, you know, the inverse is true. When you want to do hair removal, you want to treat big areas quick, no problem. Switch and change your light guides. I think the length of light guide, I often get comments on. Our light guides are much longer than most of the people's. And I think, do you want to say something here? Is that pops up?
Yeah, just that really, that they are built with the operator in mind. So they're actually the perfect length so that as you're looking down from, you know, the head of the treatment bed, looking toward your client, it's long enough that you can just see the tip of the light guide without needing to turn your head, you know, this way or that way. So you're much better in terms of, you know, repetitive strain, being able to just use these longer light guides. And also you can just see where you're going. I mean, it amazes me that there are still IPL handpieces out there where the guides are flush to the handpiece, so you literally you can't see at all where you're going on the skin. So it's just a simple thing really, but they make such a difference in the treatment room.
Yeah, again, it's about being safe. You know, I want to make sure that when a practitioner uses an IPL and they place it onto the target, if you're doing pigmentation, it's a great example. You want to put your light guide on that small piece of pigmentation. That's all you want to do. So having the clarity of seeing exactly where the tip is really important. I think the last thing then is just, again, light guide versus the lamp. a lot of IPLs, if you look inside them, you'll see the electrodes just poking out from the edges of the crystals, and that's great. You know, you've got your lamp in there, and you want to advertise the biggest area possible. So I've got a great big crystal in there. It's as long as I can possibly make it, but in fact, it's too long really, because in some other IPLs, if you can see those electrodes just poking out through the crystal, and what you've actually got is not a uniform delivery of light. So the intensity of the lamp is always most in the middle. So if you've got your crystal and you can see the electrodes, that's the edges of your lamp. And you'll find if you measure the output fluence across that crystal, the edges will be less intense than the center. So again, it's a bit like, you know, you're doing a treatment. Either your middle bit will be perfect, but you won't be zapping the hair at the edges because it's not strong enough. Or you've got it strong enough to zap the hair all across the whole surface of the crystal, but the middle is so intense that you've got a high risk of damage. You know, it's too intense because it's inconsistent across the crystal. And people will do that because they want to make big crystals and advertise big areas. You know, I've got a crystal, the bigger the area, the faster you can do a treatment. So what we've done is we've limited our crystal. It's still large. In fact, it's one of the largest on the market. But it's still large. But our crystal isn't so big that the lamp, it's actually shorter than the arc length itself. I think the next slide shows you what I mean. So our largest crystal is still shorter than the arc length, which means that we take light just from the center bit of that arc. It comes down the crystal, and it's very, very consistent across the whole surface output. So you don't have to worry about the edges being less intense or the middle being too strong. It's very uniform across the whole crystal. So we could have made bigger crystals, but we haven't done that because we want to make sure we get a very uniform and consistent output. Again, it's making sure that it's a safe and effective treatment, and these things all work in balance together.
It's a balance as well, though, between the spot size and the rep rate, the repetition rate, because if you just look at the footprint, you know, if you're looking at a device that's got a very large spot size, but the rep rate is very slow, so that's how quickly does it actually emit its shot. So there are still systems out there, very popular systems, that have rep rates of between 3 and 5 seconds. So you do a shot, you've got to wait 3 seconds, 1, 2, 3, before you can do another shot. So that really, you know, negates the large block. You know, you could actually do a much faster treatment with a Lynton system that's firing 1 every second. So that brings us to the end of the science bit, and I guess just to conclude, this is all about this bit, the results. You know, it's about being able to treat all those different skin colours, with whether they've got thin hairs, whether they've got thick hairs, and getting fantastic results on them. And I mean, we certainly do. For anyone who is considering the purchase of a Lynton device, you know, then get in touch with us and we can put you in touch with some of our users who are on this webinar. In fact, if you are using an IPL and you're getting good results, Lynton IPL, and you're getting good results, just drop that into the chat now. Tell us about some of your experiences. Tell us who you are. That would be fantastic, and we can share that with the room. I know this one is from Kerry Belber at Laser Skin Solutions. She's had an excellent result here on some vascular lesions, quite thin vessels, tricky to treat. This is actually a great result on a port wine stain. So port wine stain being really, really dense matrix of vessels that's very, very difficult to treat. This is why we would say the Lynton IPL is a medical grade IPL, because it can treat more medical concerns, not just cosmetic concerns in the skin, but those advanced, more medical concerns. Something like rosacea here, where you can't even see the vessels, you know, in some of these areas of skin, because they are so thin and fine. And I can tell you now, if you don't have that 1 millisecond or less pulse duration, then you're just not going to get, you know, the fantastic results on this kind of condition. And then of course pigmentation, so we get brilliant results on a range of, you know, solar lentigos, sunspots, as you can see here. And this one as well. It's actually the darker ones are the easier ones to treat because there's a lot of target there. It's like having a thick hair.
Helen Campbell says he's mine. I'm not sure which picture it was, but thanks, Helen.
Oh right, is that the hands? This one? Yeah. Good result, Helen. Well done.
Yeah, that's the one. The hands.
Yeah. These are tricky because they're so pale in colour. And again, this is, you know, will you get a result or won't you? You need a very sophisticated IPL to get a result on pigment that's very pale in colour, because there's not that much difference between the colour of the sun damage and the colour of the skin. So you need something that's able to, you know, get a result on the difficult types of pigment like this one, as well as just the big dark ones like this one, which do come off quite easily. So it's just one session with the Lynton IPL.
Hayley, just another question. All Lynton IPLs have 5 or 6 pulse options, don't they?
No. So if you're using a luminette, that doesn't. So the luminette doesn't have dynamic reflex. So we're talking for dynamic reflex, you would need to have an X light, a 3 Juve, or a Lumina, and it would be a Lumina that's a 500 series or above, I think, but I can double check that. Certainly if you've got a 650 advanced handpiece on your Lumina, then you've got dynamic reflex. So this is acne, as you can see, great results on acne. This is with the 5 sessions of IPL with the 585 handpiece. And yeah, I'm just going to I'll go through and talk through the different machines, but I guess now is a good time to stop and see if anyone has any questions. And just to
Kate
run.
Thompson was asking about some of the results, Katie Thompson, sorry, about, I think, on the pigmentation. It'd be great to get some of those parameters used, published somehow, so people can, I guess, recreate them.
Okay, so Sean's put, I have the Exelite, it's incredible, great results and great support from Lynton. Great to have all this update knowledge and training, definitely learning some great alternative techniques. Oh, that's nice, thank you. Yeah, so parameters for the faded pigment, yeah, we can get those parameters over for you. And then Helen's going to put hers on Instagram later. Yes, so the 650 Advance uses sub-millisecond pulses, yeah. Interesting question before from Christina, who asked, does it go for lasers? We talked earlier about, you know, if you've got flash lamps that are doing 200 million shots, then, you know, the fluence will be really limited. 200,000 shots, the fluence will be really limited. That is just IPL. So lasers operate differently, and it's not unusual to get highly effective lasers that do 200,000, 300,000, you know, a million shots. So it is different with the IPLs. Great. Any other questions then before I'm just going to give an overview of the.
To ask if they can order the small round light guide.
Yes, so we're doing 20% off the small round block at the moment, Sean. So we can drop you an email after this if you like, and you can order that.
Yeah, it's a great add-on if you haven't got the small light guide. The round light guide is fantastic.
Yeah. Okay, for the example of treating darker hair and using a longer pulse width, are we able to select this or just fluence, pulse number and delay? Yeah, so you select fluence, pulse number and delay. We've purposefully put a restriction in there on the pulse on times because these need to be delivered with the right mixture of pulse delays and number of pulses. So for a safety mechanism, that's built in there. If you and so there's like would it be an algorithm, John? Is that how you explain it? But it's a very complicated bit of software built into each device which determines the on time.
That's exactly right. Yeah, we have like a specialized curve, like an equation that maps out the energy out for the energy in. So what electric current goes in, what it'll produce out. and that's what's monitored by, we have special software built into the chips actually. It's our own unique design called PulseGuard, and the latest ones have PulseGuard 2 on it, and they just monitor precisely that current going through the lamp and how that's converted into light.
Okay. So the three devices at the moment which have the DynamicReflex are the Lumina, and the Lumina is a brilliant multifunctional platform. It's a medical grade IPL, but also can have laser added onto it. So this would be the long pulsed ND YAG, which would give you hair removal on skin types 1 to 6, and would also give you things like skin tightening, fungal nail reduction, and vascular lesions in the legs. So the thicker, deeper lesions in the legs, you would use your long pulsed ND YAG to treat. And then you can also add on an active Q-switched laser. So this is really unique. Very, very few platforms combine an active Q-switched laser with one additional technology, whereas we have 3 additional technologies on this platform. And the active Q-switch is for tattoo and for pigment removal. And that's in 2 wavelengths, a 1064 and a 532. And then we also have our award-winning resurface handpiece, which is an erbium laser. It's an erbium fractional ablative laser. So this is for retexturizing the surface of the skin. If you've got a Lumina and you don't have one of these, get in touch with us and just borrow it for a month. You will love it. You will not want to give it back. It's absolutely brilliant. So I definitely credit I've been doing quite a few webinars and people have been asking me what I'm using on my skin, and I definitely credit this erbium handpiece for, you know, beautiful, like soft, smooth, silky skin. It's absolutely fantastic for retexturizing lumps and bumps, eradicating lines and wrinkles, particularly those really stubborn nose to mouth lines. Oh yeah, Barbara's just said your fractional handpiece is amazing. It is amazing. This is it's good for just so many different things. On the scarring, the results we've had on acne scarring has been amazing. On stretch marks, you can get very good results. Congestion, lumps, bumps, all sorts of different things. So that's a nice add-on to the Lumina. If you don't have one already, then take one on a trial for a little bit and you will love it.
To point out, Hayley, the Lumina's got the power supply is designed to do IPL, all those different things, and Q-switch laser, but that's very unique as well, because we've got sort of some patented technology in there to run all those different handpieces, and the Q-switch is a difficult thing to do in the power supply itself, but that's our patent, so that's why if you've got a Lumina, you can do it.
Mm. For those of you who want a really good value multifunctional device, then the Exley is brilliant. So you've got full DynamicReflex technology within here. It will do hair removal, vascular lesions, pigmentation, acne, rejuvenation. You can also, with any of these devices, deliver the IllumiFacial treatment, and the IllumiFacial is just a way for you to maximize the revenue from your device. It really, really helps you upsell things like vascular and pigment treatments into full photo rejuvenation or IllumiFacial treatments, as we call them. So we've got a separate webinar on IllumiFacial, which goes through all of the skincare and how you deliver an IllumiFacial treatment. But to add this into your practice, it's a really low level of investment, and it just gives you, you know, a really good set of marketing tools to market your photo rejuvenation or IllumiFacial treatments. And then we also have another device with that 585 handpiece on with the DynamicReflex, and that's the 3Juve, which is specifically for skin concerns, skin solutions. So no hair removal on this one. It's an anti-aging rejuvenation specialist platform all about the skin. It's got that brilliant erbium laser on for the lines, wrinkles, surface texture. It's got the DynamicReflex in for all of the pigment and the vessels. And then it also has a radio frequency handpiece in as well. So that's for skin tightening. So pretty much anybody that walks through the door, from a young rosacea to an older acne to scars, stretch marks, to lines, wrinkles, you know, you've got loss of laxity, you've got an option in this device to treat all of those things. So a really great piece of equipment that you can mix and match put people on really advanced treatment courses with it. So that one is a definite must if you've already got your hair device and you're looking for something that's very skin focused. So we are running this week an Exley webinar, so tune into that, and we'll do 3 Juve and Lumina webinars in the future as well for those of you using those products. I think that's us. Is there any other questions or anything else from the audience? Anything to add, John?
No, that's fantastic, Hayley. Thank you very much for hosting us. I hope it wasn't too technical and detailed, but it's hard sometimes to balance all the stuff we put into this device. It's great to have the opportunity to tell people how it's been done and how it's been designed, but it's I understand it's always a fine balance between that and too much physics. So
well, interestingly, Robert's asked a question. I think this is a really good one. How do you, so we've done this very much in a business to business format, haven't we? We're talking to you as educated business owners. You already know a lot about IPL, so we can, we spent an hour and a half talking about what makes our IPL unique. You can't do that to a customer that's ringing up on the phone and try and get all this across to them. So I think that, what we'll develop over the next couple of weeks is we'll put together some extremely short consumer dynamic reflex messaging, and if you watch our Instagram, we've already started to filter this sort of stuff in, and our Facebook as well, so keep an eye on that. But essentially, if somebody calls up and they say, well, what makes you, why should I come to you for IPL? I want a laser. Why don't you do laser hair removal? I've heard IPL isn't very good, then you can answer that question in just a few short sentences and then bring them in for a consultation and then go through it in a little bit more detail. But essentially, I would be saying to someone, no, not all IPLs are created equal. A Lynton IPL, we've got an award-winning Lynton IPL. They're the biggest IPL manufacturer in the UK, British brand. And what they actually do is they deliver their IPL with DynamicReflex. And what that means is that it then becomes medical grade. So this is not a beauty IPL, it's medical grade, and it's designed to mimic laser. So you will get results as good as many, many other lasers out there on the market. Come in, have a consultation with me, we'll go through that and talk about it in a bit more detail. So just kind of award-winning, medical grade, mimic laser, those sorts of key words to just get into a very quick sentence on the phone with people will mean that you can convert them into an appointment. But we'll work on that. I appreciate, there's an element of, we could probably produce a little script, with that in, with a couple of sentences that you can say to your customers. That might be useful.
Yeah.
Okay. Someone's just asking, why would I want to get an Alexandrite if I have Lumina Advance for hair removal? It's a good question. Results wise, there's not a lot in it. If you've got DynamicReflex versus Alexandrite, there's probably not a lot in it in terms of results at all. In fact, we know there isn't because we've run trials on this.
Yeah, I was just going to say, we did a trial up again in a hospital where they had an Alex already and used the first, when we redesigned it for the specialised reflector, and we sent our first handpiece up there for trial. They compared it to Alex and said there's very little difference in the clinical results at the end of the treatment. So, of course, Alex, even with an Alex, you could only really treat successfully on lighter skin types. So, but I don't know, if you've already got a Lumina, I don't think you necessarily need the Alex bit.
Yeah, I think so. There's obviously a difference in price, isn't there? I think that, if you were, I think it's more of a commercial decision about what you want the device to do in your business. If you want to invest in a piece of equipment that's going to be used for multiple conditions, then you would be better with a Lumina, because that one device can do the vessels, the pigment, the rejuvenation. You can add tattoo onto it, you can add erbium laser onto it. So it's a real multifunctional device and you still get excellent hair removal results. Whereas if you're investing in an alexandrite is more because you just want it to do hair removal pretty much day in and day out, you know, and you want it to be like a, you know, your flagship laser for hair removal. So that then, you know, you don't want to then be doing necessarily perhaps other things in the same room, because you just want to fill it with hair removal, and then you might have a Lynton, you know, Exley with a 585 only in the other room to do all of your vascular, your pigment, etc. So yeah, I mean, if you're looking at our alexandrite, obviously that operates in a pain-free mode, which is a really nice feature to have as well. So if you're not sure which one's right, just have a chat with us, and we can walk through, okay, well, where are you going to be based? What kind of colours of skins are you going to be treating? You know, where's the business going in the future? And there's a reason that we sell 4 different devices for hair removal. It's because, you know, different things are suitable for different people at different times. But the Lumina certainly is one of our best sellers, isn't it? It's always been a hugely popular product. Okay, I think we'll leave it there then. Thanks everybody for attending, and thanks for your lovely feedback as well. And yeah, we'll hopefully see you on some of the other webinars that we're running this week. I've got a really good webinar tomorrow on digital. So if you want to sort of learn a little bit more, do a live Q&A with us, then we've got a digital expert, Rick O'Neill, in on Wednesday doing a webinar with us. And then Richard Crawford-Small is coming in for another edition of his Renew and Rebuild webinars. So if you've been watching those throughout the coronavirus outbreak, there are a series of really good business building webinars, and he's going to be coming back on to do the next installment of those with us on Thursday. Great. So thanks everyone.
Thanks Hayley. Cheers.
And we'll see you all soon. Thanks. Bye.